Throughout history, architectural advancements have paralleled changing cultural patterns. From the ancient Romans to the 19th century Industrial Revolution, technological advancements and innovative methods of material manipulation have led to new architectural form. In turn, the fabrication processes have been rethought and adapted to such demands. No longer is the house an engineered reduction of the machine. Factory production is no longer a means to mass-produce standardized components. Now, variation in complexity is just as achievable as repetition. Society as a whole has departed from the constraints of a single, nearly universal consumption standard and has evolved into the heterogeneous society of the multitude. According to Robert H., both tools and designs are interdependent upon each other. The creative use of a tool should include opportunities for the designer to embed his own design logic within that tool. Now, not only are the designs a creative manipulation of space, but the tool itself is manifested as a knowledge-based mechanism for the production of such designs. Here, design and fabrication are intertwined, whereas design is fabricated and fabrication is designed. The fabrication system is an evolutionary process where form is the formwork. Differentiation and variation occurs as each panel layer is directly dependent upon the previous one. Digital fabrication offers architects a first-hand experience of gaining an explicit control over the fabrication and manufacturing of architecture. Digital fabrication methods make connections between design decisions, material properties, and construction procedures. Hands-on research through prototyping and evaluation has resulted in a cohesive understanding of material properties, limitations, control, and variables. It is this recursive feedback loop of information, analysis, and reinterpretation that allows emergent behaviors and patterns to become apparent. A series of geometric investigations reveal the possibilities of connecting successive panels end-to-end for linear assemblages. Prototypes 14, 15, and 18 are assembled in a linear array. Further geometric analysis revealed the specifics of these connections. Distances between shared vertices in the x and y directions are calculated, and the resultant function between the two determines the geometry of a shared edge condition. In order to evaluate this logic, a predetermined surface was reverse engineered into a field of panels. Beyond flat surface geometries, the system is capable of creating domes, fully flexible shell structures. 15 identical formworks were uniquely etched and cataloged for casting and assembly purposes. The resultant form demonstrates three-dimensional flexibility. As the S-shape bends in the X and Y direction, the form also tapers inward and outward at the top and bottom, allowing for a self-supportive shell. Traditionally, individual molds would need to be made for each unique panel. Although sophisticated software today can identify similar geometries on a panelized surface for formwork reuse, stackable fabrication allows the reuse of formwork with the benefit of generating multiple unique panels. Furthermore, we are capable of accessing and modifying the code of our current technologies, such as a CNC router, and instructing it to precisely dispense concrete into the mold through a customized nozzle attachment. This now becomes a deployable system, blending the line between prefab and cast-on-site fabrication. The system is infinitely continuous as more and more layers and formworks are added. The properties of this unbounded expandability largely led into an investigation of continuous surfaces. The batwing minimal surface is a mathematically derived differential equation in which surface continuity is bound by a network of curves. Site-specific aggregation is based on existing automobile, bus, and trolley circulation, as well as pedestrian access from the nearby intersection, bus stop, and from the business park to the south. Connections between these nodes create complex spatial conditions and circulation routes. These forms not only respond to local conditions, but augment complex social functions inherent in contemporary society. The Gillespie Field Trolley Stop is located in South Santee in eastern San Diego County. Two business parks border the trolley station to the north and south, a typical suburban neighborhood to the west, and Gillespie Airfield to the east. The site is bisected by a water basin parallel to the trolley tracks, requiring bridge access from the west. The current trolley stop is a hub for multiple, presently disjointed modes of transportation: bus, bicycle, automobile, pedestrian, and trolley. The trolley station complex integrates all five. Surrounding the complex is a multitude of seating areas and meandering paths. I provided an area on the northwest side for the local Santee Farmers Market on Wednesday afternoons, currently held in this abandoned parking lot. During the rest of the week, the space functions as a covered area for bikers and joggers to take a break. The ramp to the left leads to a covered gift shop above. Around the corner is the main entrance, leading to an inner courtyard with adjacencies to the ticketing and concession area, covered parking, trolley bridge access, and seating areas above. By implementing a turnstile element into the San Diego public transportation system, the city will be capable of generating enough capital to fully fund the project as well as more of its kind. The result is an architecturally unified public transportation system with locally adapted programmatic conditions and a source for steady economic gain. Passing through the ticketing area, a ramp leads to the second-level bridges, where there is access to the information kiosk, a secondary trolley access point, and the eastern side of the trolley line. The restaurant is separated from trolley service programs as it will primarily serve the general public and daily lunch crowds from the nearby business park and Gillespie Field Aviation School. This area showcases the ability of the fabrication system to formally integrate terrace seating areas, bar top division, and roof structure. Typically, specialized professionals would be subcontracted for each installation, but now one comprehensive fabrication system allows Form to adapt to specific programmatic requirements, effectively putting the designer in full control of spatial manipulation. We are no longer reduced to the constraints of value-engineered spaces that are merely good enough. A solar analysis script was used to determine optimum surface perforations for daylighting and passive ventilation. Here, adaptive fenestration is applied to the information kiosk, adding another layer of complexity to the final design. These perforations are implemented in the panel's fabrication phase, where form is embedded within the formwork prior to casting. After the material has cured, the void can be removed and the result is a continuous panel differentiation of both overall geometry and aperture size. The blue areas in the structural diagram highlight areas of weaker structural performance, requiring additional reinforcement. Also applied at the fabrication phase, the formworks are pre-threaded with rebar and casted as usual. Traditionally, precast concrete shell structures can span 18 to 20 feet between columns. Glass fiber reinforced concrete reduces weight while adding tensile properties to the panels. GFRC allows for spans double to triple that of equal weight traditional concrete mixtures. From fabrication to realization, the Gillespie Field trolley stop demonstrates the ability of spatial complexities to become integrated into program, site, and production processes, creating moments that rethink modern architectural design techniques. Contemporary architecture is continually informing and being informed by new modes of representation, and thusly the role of the designer is returning to that of the master builder. Designs are a network of operations between mind, hand, tool, and material. These direct relationships encourage new disciplinary delegations, leading to alternative modes of collaboration among experts. These vast bodies of knowledge between professions are the breeding grounds for new emergent phenomena and allow the scope of architectural design to infinitely progress.